We're talking DevOps Archaeology, so I want to give a nod to the real archaeologists out there. And I'm going to leave an artifact for archaeologists thousands of years from now to see, to make them wonder what we were doing today. So we're going to do that via selfie. Everybody ready? I want lots of energy in here. I want all the other sessions down on the second floor to hear what we're doing, okay? Ready? All right, let's do it. Lots of energy. Yay! Woo! Louder. Come on, come on, come on, come on, come on. One more time. Let's do it. Yay! All right. Now let's go ahead and get started. So my name's Lee Fox. I am a cloud architect at a company called Infor. I've been an Agile, DevOps, and ChatOps evangelist for the last several years. Let's see, 10, 5, and 3 years respectively, thereabouts. I'm involved with a lot of user groups, so community is really important to me. Back home, I'm involved with Agile Austin, Cloud Austin, Austin DevOps. I'm an Alexa developer on the side, so that's just in here not because of my presentation today, but to let you know, I'm one of you. I'm a true nerd and geek, okay? I'm really excited about all this technology stuff. I'm an amateur chef. I am not full of enough hubris to think that I'm going to please every single person in this room, but if I do piss you off with my presentation, see me, I'll give you my cordon bleu recipe to make up for it. It's divine. A little bit of housekeeping. I am going to push the time limits on this presentation. There's a lot of material. So I can't guarantee that I'm going to get to questions at the end. I will do my best. But if I don't, I'm around for the rest of the conference. Feel free to ask me questions. Let's go and have a beer. That's a great conference question medium, so I'm down with that. But I want to be able to answer questions, just I don't know if I've got the time during this. My perspective. I've got a Java development background. I started off as a developer and worked my way up until this whole cloud and DevOps thing happened, and then I went into an AWS background. This is not to say that for the things that you hear today, Java and AWS are going to be the only ways to do it, that those are the only technologies involved. You can do it with whatever your home native technology is. It's just that this is my best lens to explain some of this material to you. So our agenda, simple. We're going to talk about DevOps Archaeology, and then I'm going to give you some techniques on how to do your own infrastructure and code digs. But to start talking about DevOps Archaeology, we have to see that it does address a problem. And I'm not going to do the hand wave. I know that every single person in here has come and experienced this problem, where you've walked into a shop or you've walked into a new project and you've looked at the technology stack ahead of you and you're like, whoa, I'm going to develop a drinking problem over this. You know, how do you get past that? And why does that problem exist? Well, sometimes the systems are complex. You don't know exactly what's out there. There's a lot of moving parts that work together. Nobody can understand every single working part. Sometimes it's just communication. How do you get information from one person to another, whether it be in the spoken or the written word? Sometimes time is the enemy. You know, I can't tell you the number of times that this one has bit me. The hero, you know, that person that has all the information, that knows every single little bit about the architecture because he or she wrote it all. Maybe that person's gone, got hit by a bus, or I guess the more politically correct term is won the lottery, but they're not there. So how do you deal with that? Sometimes silos get in the way. You know, you get it working on the developer's computer and I'm done. How many times have all of us heard that? Oh, it works on my system. But all of this isn't just a developer's problem. We can see this in the operations world as well. We see it in different ways. We see it with networking concerns. We see it with uptime and reliability. But all that architecture is still there. And what's interesting is, and what's tragic is, it all causes stress. And we have to find creative ways to deal with the stress. And sometimes they're not exactly the best ways for us to deal with all that stress. So how do we deal with all of this and find a better way to alleviate that stress? DevOps Archaeology. So what is DevOps Archaeology? It starts with this concept called software archaeology. It first appeared at a 2001 UPSLA conference. It was a workshop there. And the idea was that it was just going to help us gain perspective into an application's behavior. We wanted to understand the code. But even more, we wanted to understand just what the hell were the people before me thinking. We want to show areas that needed to be investigated. So where are my complex areas in the application? And more specifically, how do I ask the right questions to learn about the system that I'm trying to work with? Again, DevOps Archaeology starts from software archaeology. This first appeared at Austin DevOps, October 2017. Full disclosure, I created and brainchilded this concept. So the good news is, it can be argued that you are getting this talk from the world's foremost DevOps archaeologist. The idea is to apply this software archaeology concept to infrastructure and use a lot of infrastructure as code, because that's what we want to do as a best practice in DevOps and operations. We want to take that infrastructure we have, bring it over and represent it as code. That gives us a lot of great benefits in terms of how we manage our systems, but more importantly, all those techniques from software archaeology suddenly apply. Again, we want to learn what those predecessors were thinking, and we want to understand how everything works together. Somebody took my water. All right. So software archaeology has a lot of techniques and tools, and we're not going to go over all of these today because this is a talk in and of itself. I can offer that I'll come back next year and talk about this specifically, but let's go on with DevOps Archaeology. We're going to use a lot of monitoring tools. We're going to use log aggregation, automation tools, analysis tools, testing tools. And again, that's in addition to all those techniques that we saw before. So with that, let's look at the actual techniques on how we do these code digs. Generally, it's going to be simple. We're going to measure things. We're going to hypothesize about things. We're going to conduct some experiments, and then we're going to validate the results. Does this sound familiar? Kind of scientific method-like type of thing? That's all we're doing. We want to go and look at it. We want to figure out how it works. And sometimes we have to take guesses about it, but the most important thing is validating the knowledge and sharing that knowledge. So how do we do this? Well, visualization is probably the most important way that we're going to measure things, just by looking at it and observing it. So this is important because it provides easy to understand channels for us to get at that information. And really, yeah, picture's worth 1,000 words. We get so much information visually that we see things that we don't necessarily cognitively search for. It's just there in our periphery. It's information that we think about later, small little details. And visualizations do this because they provide just a really narrow, focused view upon what we're looking at, and that really helps to elevate the actual information that we're going for. Here's one of my most favorites, Code City. This is there's a URL. You can get this from the slide distributions when you get my slides. This is a tool that specifically supports Java, C++, C#. I will tell you that's limited to non-commercial use. But the idea here is we're going to look at our code base, and we're going to represent it as a city map. And in this Java code base, all of our buildings are put together and grouped by the packages that they're in, are the blocks. The buildings themselves, the taller the building, the more number of lines of code in the building. The wider the building, the deeper the building, the more number of methods that we have in there. So we represent our source code as a city. what can we do now? Well, we can ask questions like, look at this big building right here in the middle. Who wants to live in that building? It's structurally sound, that's definitely important, but it's kind of big. If you wanted to go find your neighbor on a Friday night to have a beer, is it going to be easy to navigate to where your friend lives? What about those tall, skinny buildings all the way in the back? Who wants to live in the penthouse of one of those? The wind waving and swaying all the time? Maybe not. But the idea here is we can look at this code base and we can see, are there any areas that I need to go and look at? Are there any classes that might cause me some concern? Looking at the package distribution with classes. Are there too many classes in the neighborhood? Is that the kind of place I want to live? Or do I want to live someplace that's a little bit more smaller and organized, more community-like? Gorse, this is a fun one. I believe it's a Google tool. This shows us the evolution of a code base. So it's basically looking at our source code repositories and going to be showing us a very nice representation of what's happened on the timeline of our code base. This is what it looks like. So we have nodes that are coming in. You see that there are actors and they zap to the files that they're adding and committing. Right across the top there is a date. I've used this in a lot of shops I've gone to as one of the very first things I've done to look at the source code. And I sit there and I watch it and I wait and like, well, right there. We had a big explosion on about January 23rd. This gives me questions that I can go and ask to my fellow colleagues. What happened on this day that caused this big explosion? Was there a release? Was there a big refactoring of the code? Did we re-architect something? And all of this is going to provide a lot more context to how I look at the code base and what I'm going to do with it. Signature survey. First put out by a very smart man, Ward Cunningham. And the idea was to give a quick way to scan for patterns in code. So this is a small little class from the Apache Tomcat project. You know, this doesn't look that bad. Just coming in, I can see, okay, it's a small class. It all fits on one screen. It's got a couple of getters and setters in it. Yeah, I can understand this. Okay, that's not bad. But what if the source code is a little bit bigger and it's harder to fit on one screen and there's a little bit of logic? And even then, this is not one of the more complex classes in Apache. All this is basically just a bunch of getters and setters. It's a POJO. When I start adding in more complex logic, then things change. So signature survey allows us to strip out all the stuff that is not a Java delimiting character. And it just throws out those Java delimiting characters, your open, your curly braces, parentheses, semicolons. And this allows us to scan for patterns, which when I look at this, the first time I look at it, it doesn't necessarily mean that there's a lot of context or meaning there. But I think there is. Because you can look for patterns. I can see classes where I've got a bunch of nested ifs, which as a software developer is a huge red flag for me. I can see if there are lots of import statements by the semicolons at the beginning of a class, and that's really important as well because it shows a lot of efferent and afferent coupling that's going on with my project. How many other dependencies do I have with this class? You might have some constant classes, depending upon your take, that might be an anti-pattern. Or if testability is a big one, a really big monolithic statement, monolithic method is going to be a problem as well. And the idea is I can look at this and I can quickly clue in where are the areas that deserve my attention to focus on and what are the complex areas. This is going to help me ask other people for questions. So Ward Cunningham's signature survey tool is kind of hard to find. I am creating a new one. And what I'm hoping to do is make it language agnostic. So if you would like to go and use this tool, possibly even contribute some code updates to make it better, the idea here is I want to pass in a list of characters to scan for. So we can take whatever we're looking for, whether it's going to be a CloudFormation template, whether we're looking at Python code, Perl code, Java code, and have this tool help us find exactly what we're looking for as far as those patterns of the delimiters go. Logstalgia, another really important visualization tool, but this is going to be more on the ops side of things. So there's the URL just as a reference, and what this does is it visualizes traffic to a web server. This is another tool that I like to run as soon as I get to a shop and I'm trying to understand infrastructure. This is what it looks like. So basically, I've got a bunch of IP addresses on the left side of the screen. I've got a bunch of resources on the right side of the screen, and dots going back and forth. If it's a successful request, then it's going to get bounced back with the response code. And if it's a failure, then the dots are going to pass straight through. And I can look at this and see what is happening with the servers. One of the reasons why I run this tool is because I want to know why did my predecessors make decisions about the size of the VMs that they used? Why are they allocating as many IOPS as they are? Like in this particular case, I can see that there's a bunch of static images that are coming out. That's going to be very, very I/O intensive. It helps me understand exactly why they made some of their changes or their sizings. You can also use this to look at your systems ongoing and determine if your architecture was put together to determine against like DDoS attacks and how your continual load is going, because DevOps Archaeology, as I'm going to get to later, is not just a one-time snapshot activity. It's a continually learning activity. Proxies. You can intercept your requests between machines. This is a really good way of observing and measuring your system. When you fire off a web request to your system, trap it. Inspect the headers. Look at all the packets that you've got going back and forth. Record conversations between the machines so you can actually see multi-handshake types of situations. What exactly is the application doing, and how is it communicating with all of its clients upstream and downstream, and servers upstream? I like this one quite a bit since I'm a Mac guy. This is Charles, and you can see that it does give me the ability to look at all the information within the request that's coming in. I can use Charles and replay a conversation, actually getting right down to look at the actual body of the responses that are coming in. So this is huge if you're going to try to do some digging and understanding your applications. Packet snippers, a lot of us are ops guys. We're familiar with Wireshark, TCP dump, flow logs. Sometimes you just need to go and listen to everything that is happening out on the network. This is a great way to do it. I mentioned monitoring tools. So perhaps you're in AWS, you've got CloudWatch, there's Stackdriver monitoring, Datadog, Logic Monitor, some third-party services. Very, very important. You've got a service that's out there, and it's doing exactly what you want it to do. It's observing your system. It's helping you do that measurement over time so that you can actually open up your eyes to a lot more of the breadth of what your apps are doing and what your infrastructure is doing than just by focusing upon one screen or one tool. Log aggregation is very important. So Splunk, Elk, Graylog, there's a ton of them out there. This is along the same lines as the log or the monitoring system, because it does help you pay attention to what the application's doing. But it really is going to be used more for the application understanding the application rather than looking at the code itself. Because developers love to put information, put very rich information in the log aggregators. You can use it to find errors. You can use it to look at systems and really understand what's happening. A great example is with my latest organization. When I started there, I immediately put in a log aggregator. I was just using the Elk stack, nice and cheap. And what I saw was a bunch of logs, a bunch of Java exceptions coming across in the log files. And when I saw that, it was problematic for me because I saw a lot of errors. But the aggregator allowed me to see that there was a pattern to them. I could see that once every 5 minutes, I was getting 3 Java exceptions. And every time somebody clicked on the login link, immediately after the login link, I would see 7 Java exceptions. So what it turned out was that those were exceptions that were thrown in the normal course of action that the developer just decided not to capture, not to handle, but to ship out to the log file. They were Java expections. It showed me that everything was working normally. So this allowed me to really dig down in and get that information, to see that I didn't have to panic just by looking at my application logs. There's a class of tools that I'm going to call analysis tools, things like CloudTrail, Trusted Advisor, Config, Macy. If you're working in AWS, you've got Application Insights, Cloud Security Scanners. These are going to be tools and services that, again, are along the same lines as the monitoring tool, which can help open up your visibility to the applications you're looking at, but and do it on an ongoing basis. But they're not going to be focused really upon those operating metrics, the things that we would typically think about as far as disk space or memory or just what the applications are saying in their verbose logs. These are going to be things that allow us to look at the infrastructure itself. How is my application starting and stopping servers? Am I conforming to a set of rules about the application in terms of how I'm creating all my users and such? This is information that can come from tools like this. Distributed tracing as well, another great one. This is one of my favorite tools from AWS. This is Config. So I create rules that I want to observe my system on. I turn it over to Amazon. It may be something like I want all my resources to have specific tags, or I think that's a good hypothesis. When I start that rule up and I engage it, then Amazon does the work for me, and all I have to do is sit back and listen for the alerts that will either confirm or deny the hypotheses that I'm trying to make about how the system is operating. Trusted Advisor, another great AWS tool. They've taken a lot of the knowledge that is built up in their solutions architects and embodied it into a tool that is sitting there continually looking at your system to help you decide if you've got any problems as far as security, fault tolerance, maybe your cost or your performance is giving you problems. But you can again just tie into this. It's a passive, and it's looking at the system characteristics of your infrastructure. Macy is another great one. Ties into AWS CloudTrail events and also some of their S3 usage, and can help you graph exactly what people are doing. It can show you where those APIs are coming from. So I use this at Infor as well when I started putting together some of the architecture there to get an idea of how the cloud is being used there. I wanted to get an idea of where the actual AWS activity was happening from. When people were making API calls, were they doing it from our office? Were they doing it remote? Is that a big deal? Actually, for me, it turned out to be, because a lot of our systems required VPN tunnels, VPN connections to get in, and I needed to have that information to begin to plan for a lot of the architecture coming up. So that usage information turned out to be very, very valuable. All right. Now that we've got all the different ways to measure, we need to begin to start to look at how we can put together some experiments and work on them. The first thing is you have to have source control, because you need to keep track of your changes. When you go to make experiments, you definitely want to create experiment branches. You want to branch off of what you're working with, make your changes so that you're not going to pollute the work. Keep in mind that we want to be as sterile about the artifacts that we're working with and that we're conducting experiments on in our archaeological digs. You can also use this, by the way, to continue that thought of monitoring or measurement. You can analyze your history to date. We saw that with the GORS tool before, but also in terms of the company's branch strategy. How do they do the development? Where are all the changes made? Where are the releases made from? You get questions to ask. If you end up with source control where your Git branch looks like Guitar Hero, you've got a lot of major questions to ask. So make sure that you've got the source control. Again, it's going to help you organize yourselves in the experiments that you do. You want dependency analysis in place. See what the dependencies upstream and downstream are. And this is absolutely critical, because you want to make sure that when you're making your changes, that you're not going to break anything else, or at least you have an idea of what you're going to break. If I'm making a change to class X, I want to know if it's going to affect behavior in classes Z and W. And the same is true with my systems. If I'm going to make a change to an EC2 VM, I would like to know if there are any other virtual machines or any other services in my architecture that I'm going to change. So we can look at a lot of dependency analysis tools. This is JDepends, open source Java analysis tool. And it allows me to look at entire packages. This is Spring OGSI, and there's a column right in the middle, C, A, and CE. Those are dealing with afferent and efferent couplings, the different ways that our classes reach out and depend upon each other. So we can see that there are some classes here that really depend upon others more than some of the other ones that exist in the same package. And you also get complexity scores in here as well. You can see it with Maven. If you're looking at it from an infrastructure standpoint and you want to know what the actual binary dependencies are between all of the artifacts. Okay. So we've got, what do we have? We've got our ability to measure. We've got an ability to keep control of what we're going to do. And we need to then take the experiment further and actually do things. So look at testing tools. You want to be able to poke the box and exercise your application. So on the software side, definitely unit testing, that's important. But for the infrastructure side, it's going to be more end-to-end testing. You want to drive that whole system so that you can see all the changes that are happening as it cascades throughout your architecture. And be sure that you're looking to drive full stacks or UIs. So if you're able to do that, you'll want to validate things. You're going to learn information from your testing once you fired off those tests and confirmed your knowledge. I say validate the knowledge, and the best way to do it is to duplicate the artifact. So configuration management is a great way to do that. If I've inherited an architecture, a legacy system, I've observed some information about that, and if I could rebuild it, then I think I've got the best possible validation. Configuration management, Ansible, Salt, Chef, Puppet, Capistrano. A lot of these tools are great ways for me to re-provision applications automatically and do it reliably. It is a great way for me to even drive tools like CloudFormation or some Kubernetes tools and Docker tools to help build a lot of the infrastructure that is necessary, to even drive AWS APIs to, again, build infrastructure and help me definitely replicate that stuff. So it's much better for automation than shell scripts because it's idempotent. All these frameworks are. And this is important. When I go to run my experiments, they are definitely a repetitive activity. So I want an idempotent framework that's going to allow me to be sure that I can run my validation again, my rebuilds or my reprovisionings, testing my knowledge, and not mess up things that I've already deployed and have out running. So we're getting close to the end. We can talk about some dig techniques. I definitely want people to do this at the start of an engagement. But as I mentioned, while it's going to be beneficial to give you questions that you have to answer, it's also a continual activity. You are always going to learn about your systems. And I think that we already just can take that as granted. How many people have learned something new about your systems with a production outage? Yeah, I didn't know it did that. I didn't know I had to keep all those VMs up and running. I didn't know I had to keep my firewall open all the time. You're going to continually learn, and a lot of these tools, especially the analysis tools I mentioned, the monitoring tools, some of the things like Logstalgia are tools that can run continuously. So refer to them over the life cycle of the engagement and your tenure with the project and technology. You might wonder, well, how do I get started with DevOps Archaeology back in my own shop and on my own legacy systems? So the first thing you want to do is you want to come up with a list of questions that you want answered. What are you curious about as you come in? And they might be, what are the most important components of the system? How does the system work? It's whatever is going to be important to you. You're going to have to just pick a starting point. I mean, typically, in the past 10 years ago, the starting point didn't really matter because the systems were much smaller. But now we've got much larger, more complex systems that are N-tier, thousands of servers running. We've got various data centers involved. Things are replicating. Just pick a point and begin to build your base of knowledge around that. You're going to have to select some measurements, so find things that are going to give you some quick ability to measure. I suggest looking at your monitoring tools, log aggregation, as quick ways to start disseminating information out. I also suggest looking at something that is not as intrusive to put into a full running production system. Gorse and Logstalgia are both non-intrusive that can help give you some information about the legacy and of the application. Create some experiments. Run your experiments. Again, be safe about it. Most of these times you're going to be looking at legacy systems. If you can create a UAT system or a dev system, that's great, but remember, you're not going to get a lot of the same performance characteristics that you will get from a production running system. And then just iterate. Do it again and again and again. As long as I've been doing DevOps Archaeology with my Infor products, I have not stopped. I just started 3 more experiments last week before I came here because I needed to understand exactly what was happening with some legacy portions of one of our systems for taking transactions and how all that information was being handled. So, you're thinking to yourself, hey, wait a minute. All you've talked about is tools and technologies, and yeah, you're right. You're absolutely right. And I know DevOps is more than that. It's about people and processes, and this talk didn't cover that. The good news is The next one, DevOps Anthropology, does. It is currently being authored, and I'm putting a lot of research and work into it. So Joe, next year?
Look forward to it.
All right. Here's a bunch of sources that I put together for this talk. And then if you guys need to get in contact with me, I will take emails. You can ping me on Twitter. That's a quick way to get to the slide deck with the QR code. And of course, as I mentioned, hallway conversations and beer, great question media. That's all I've got. So before you applaud, I want to thank Situation Publishing. I want to thank Joe. I want to thank Julia. I want to thank Relish with Cassie and Millie for all their help. Continuous Lifecycle London, thank you for making me feel so welcomed here.